Welcome to episode 123 of the Actual Astronomy Podcast. This is the Objects to Observe in the June 2021 Night Sky Edition. I'm Chris, and joining me is Shane. We are amateur astronomers. We love looking up the night sky, and this podcast and our podcast is for anyone else who likes going out under the stars. Shane, we should mention something first, and that is that these go out on the 365 days of astronomy, and we actually release 2 episodes a week, sort of on our own, and a couple episodes a month through the 365 days of astronomy, which is awesome. But I think now we have over 120 podcasts, individual episodes that we've recorded over the past year and a month.
Yeah, great point. And some of those podcasts are stale dated, meaning, there was information about a particular event or, what to observe during a particular period. But many of the episodes are very reusable or still relevant. We talk a lot about gear. Some of the constellation talks that we do are still valid. And if the constellation isn't visible right now, just wait 6 months and it probably will be. So definitely check out the backlog if this kind of podcast appeals to you, if you're a visual observer.
Yeah, sounds good. And we often put in the variable of the month. We've been doing that for a couple months now since we talked to Dr. Stella Kafka, who's in one of our previous 365 days of astronomy episodes. And this month, though, with our recording cadence, we still have the May one up there when we're recording this. So we encourage people to go to the AAVSO webpage at aavso.org, and then you can look up the variable star of the month if you're into variable stars, and they'll have a nice video up there by the time this podcast goes live.
Yeah.
All right.
Good advice, good recommendation.
Sounds good. So for objects that we're looking at, we've got some interesting events that are happening this month. Recently, there was a lunar eclipse on the 26th of May. And we had some listener photos that were sent in that were really cool to see. And then I was watching it, just not live online, but I watched some recordings of it out of the Southern Hemisphere, which was really cool to see. And then we'll also have a sort of the conjoining annular solar eclipse that's going to happen this month. Although I think for traveling to that, it's probably not recommended. Anyway, from where we are to where it is in our country, there's a very large COVID-19 outbreak, unfortunately. So there's stay-at-home orders between where we live and between where the eclipse is. So we're not traveling for it this year, unfortunately.
No, it's too bad. You and I had talked about this probably 6 to 12 months ago about potentially making the journey. And, I was definitely excited at the potential, but also very cognizant of the COVID potential impact. And unfortunately, we won't be able to make that drive. But for those that are near the annular, that's a pretty cool thing to see, and definitely put it on your calendar. And I guess we'll talk about that here probably shortly.
Yeah, and then we have a decent planetary lineup this month of Venus, Moon, and the planet Mars around mid-month. Should be good.
Yeah, lots to look at.
So Mercury's really too close to observe in the June 2021 night sky, and Mars is moving west from Gemini, while Venus moves east from Taurus, and they both eventually end up in Cancer, which is sort of like of a mid-spring constellation. So then that means that these are going to be getting very much into the western sky during the evening time. And really, there's not much to see on Mars. Shane, I think you were the last person I know that took a look for much on Mars, and it's getting pretty small now, I think.
Yeah, it's almost stellar in appearance, meaning it almost appears like a star even through optics. Mars is a pretty small planet, and it's quite a long ways away from us. So as it's gaining distance from Earth, and due to its small size, it's hard to resolve it even as a disk with a modest telescope. never mind trying to see any of the surface features. So, at most, you'll probably just see a small red or orangey circle, and it might even just be a small orange, reddy star-like thing.
Yeah, and see. Venus on the horizon, and there's some pairings with Venus, which would be worth looking at maybe with binoculars or small telescopes. But of course, in the northern hemisphere where we are, this is the time of year where our dark skies are very much reduced by the height of the sun in the sky, and in fact, where we live, we get perpetual twilight for about 5 or 6 weeks here now. So with that. We may be able to see Venus. It'll be very low on the horizon when we do. The further south you get, though, and into the southern hemisphere, Venus becomes a more attractive object.
Yeah, for sure. I'm looking forward to that. You and I did a lot of Venus observing last year, trying to see some of the detail within the clouds, and we were successful. And I want to try it again.
Yeah, I am. I'm eager to do that as well. I think probably the better bet is going to be later on in the year. What did you see as far as detail goes on Venus last year, Shane?
Well, there's sort of a sideways V that would stand out a little bit to me. Then I have to check my observing notes. I felt like there was kind of I thought there was like some bright blotches or spots almost, if I remember correctly. And then, of course, there's just the phases of Venus, right? It's similar to our moon in a way in that it has different phases that you'll be able to see through a telescope.
Yeah, and I had some pretty good conditions from time to time, and made some decent sketches of it. And then I was actually writing a journal article about sort of whether or not can you see the cloud tops on Venus. And just as I was putting it together, there was an individual in Europe, and I think they were in France, and so about as close as you can be and still be in Europe to where we are, which is still 8 or 9 hours time difference. But they did capture within that 12-hour period anyway. Similar features to what I had sketched, and so I was able to kind of get their permission and use those in my article. And you can actually see that while the clouds had actually shifted a little bit and had maybe sort of broken apart or something like that between when the photo was taken and when my observations were taken, that sort of undoubtedly they were very likely the same features. It seems unlikely that coincidentally I would have sketched this sort of strange Y structure on Venus, and then just within about a 12-hour period of time, somebody would have taken an image of a sort of a broken Y structure on Venus, and then sort of got this pole light, very light shading, very bright white clouds on the pole, which I also had put in. So it is from good skies and small telescopes, you can actually make out some features on Venus. It is possible.
Yeah, and if anybody attempts these Venus observations, be aware that these features do not jump out at you. They're not. No. They're not super easy to see. Like, it's not like seeing the bands on Jupiter or Saturn's rings. Seeing any kind of Venus detail really requires a lot of time at the eyepiece, a lot of patience. You kind of need to wait for you just need generally good sky conditions, but then also while at the eyepiece, the seeing kind of varies because Venus is so low in the horizon, and you just have to wait for those real brief moments of clarity. And then sometimes this detail will pop out, but you can also go multiple nights on end without really seeing any of this, and then all of a sudden it'll be there. So persistence and patience is required for any sort of Venus detail.
Yeah, I always like to think of observing Venus as a lot like fishing. There's a lot of sitting around in the boat with your line cast into the water, and you just need to enjoy that experience. If you don't, you're not gonna catch any fish.
Yeah, good analogy.
Some easier fish to catch are Jupiter and Saturn, and these are the gas giants that are continuing along. They're somewhat separate ways, although they're still sort of in the sky at the same time when they're both sort of getting towards their maximum height that we're going to see them at in the morning skies down there in Capricornus. Well, Jupiter is just coming into Aquarius now, but they're both high enough in the morning sky to become really good telescopic targets. Have you been out to see them yet this season?
Nope, not yet. Most of our listeners, I think, know this by now. I'm not much of a wake up in the morning at 3 a.m. observer. I'd much rather stay up until 3, but so not yet for me. But I think you did.
Yeah, I am somebody who likes to get up in the middle of the night, and this is one of the reasons how I think maybe I became so latched onto astronomy at an early age. I would often wake up at 2 or 3 o'clock in the morning and then just be up and. When I get into astronomy, I would make good use of that time, as I have been recently, and started making some Jupiter and Saturn observations. And yesterday morning, which is sort of one of the last days of May, had some great views of the cloud bands of Jupiter and the beautiful rings of Saturn. I could just barely see the Cassini division, which is a large gap in the rings of Saturn. Using just over 100 power in a 60 millimeter telescope, which is just a very small telescope. I'm not using anything really that large. It's just a good quality little telescope. And they're now high enough in the morning sky for us anyway. We're at 50 degrees north latitude. And so for those south of us, if you do get up in the morning, and these nights, although we have to get up in the middle of the night, if you're much further south, you can get up a little bit later, maybe 4 or 5 o'clock in the morning, even if you're far enough south to see them in your south into the southeastern sky. You'll see Jupiter is extremely bright now, and then Saturn is a fair bit fainter. And it's almost due south by the time the sky is getting quite bright. Saturn being more just high into the southeast.
Mm-hmm. Yeah, I'm looking forward to them. Getting higher and higher in the sky, earlier and earlier in the night, so that it becomes a little more accessible.
Yeah, we'll talk about how to track them down. Like maybe for people that are these are sort of like telescopic stuff. We'll talk about how to kind of track them down if you haven't even really seen them before. You can see them with your eye. Neptune and Uranus, though, to kind of sort of close out our planets, they're too low. They're too low on the horizon to really see, and apart from some lunar pairings, which we'll mention, they're not really visible. So June 1st. So right at the start of June, that is going to be on Tuesday. I think this will come out on Thursday, so it'll be a little bit past that. But for those that are subscribers, maybe they'll get this early. June 1st, Jupiter is going to be just 5 degrees north of the moon. So in the same binocular field, if you have a decent wide field pair of binoculars, you'll be able to see this pairing. And even if you're hearing this after that time, you can always go to a website like skymaps.com and you can download their free sky map there. And you can actually see on the left column, there's this page, it has a star chart. And on the left column, there's a list of when these pairings occur. And you should know that on many months, the moon will pair up with the planets nearby in the sky, and then that can help point them out. So next month, this might fall on a better date for us to see. And then on the second, that's going to be the last quarter moon. So anyway, as we get into the 6th, the asteroid Juno reaches opposition, and it's going to be at magnitude 10.1. It's located in the constellation, and it's sort of on the left side. So if you want to see an asteroid, if you want to see the asteroid Juno, this is probably your best chance for the year, but it's fairly faint. I don't know, Shane, have you ever tracked down a 10th magnitude asteroid before?
No, I really don't spend a lot of time with asteroids, but anything that is a moving object in our solar system, I do find interesting, and I might give this a try. Just to see what, if I can capture it or not.
So how would you observe if you were going to go out and try to observe? So 10th magnitude, first of all, this is faint enough that you're really going to need to have like a good little about 3-inch telescope or so, I think, to have a decent chance of seeing from a reasonably dark site, correct?
Yeah, for sure. Yeah, you would definitely need at least 3 inches of aperture. Dark sight would help. And then what you would want to do is try to observe this at the start of your session. And what I would do the best thing to do would be to sketch what you think is the asteroid, as well as all of the stars around it in that field, and then come back to it in a couple of hours to see if what you think is the asteroid has, excuse me, has moved in relation to those background stars.
Mm-hmm.
And then that's how you really confirm whether or not you captured the asteroid, because it will just look like another star. We should set the expectation that you're not going to see any surface detail on these things.
Mm-hmm.
It is really just a point of light. And it doesn't move enough in the eyepiece typically where you can kind of watch it just pass by. So it does help to, like I say, record its position at one point in the night and then come back to it to see if it's moved.
Yeah. And I only just raise that because this is just when it reaches opposition, and it's noted. Some of the stuff that we do mention here, it might be difficult to see. And you might say, well, why are we including that? Well, the reason why is that this is actually out there on the feeds. Like if you look around, it'll say like Juno is at opposition tonight. Well, how would you go out and see it, or it's at opposition in June? So it's the best time to see Juno, the asteroid. However, this would be, I think, difficult for most people to accomplish. So that's one of the reasons why we put some of this stuff in, so that if people are reading that in places, then they can kind of look to us and say, well, can I actually see that or not? I think this is something that somebody who is sort of an experienced amateur astronomer might find interesting. But I think for a lot of people, especially those that don't have telescopes and might be just looking at the sky with binoculars, this one I think is going to be too challenging.
Agreed.
Yeah. Moving up, this one's a little easier, but again, not too eventful. On June 7th, we have Uranus, which is just going to be 2 degrees north of the moon. So this will actually fit in the field of even like a medium size, like maybe even like a 6 or an 8-inch telescope. We get them in the same field, but it's very low in the morning twilight. So I think again that is just probably not going to be something that I would say get up and take a look for, Shane. If I'm up, I might take a look. I see that for us it occurs the best opportunity according to my software is going to be at approximately 4:00 in the morning. So
yeah, I think if I was up at that time, I would be spending my time on Saturn and Jupiter.
I thought you were going to say drinking coffee.
Well, that too. There would be definitely a coffee very close to me.
Yeah, I know. Yeah, it's definitely one of those things. So, but June 10th, this is kind of the sort of the big event for the month, is the annular solar eclipses. Put this warning out first that an annular eclipse is not a total eclipse of the sun, is it? What is an annular eclipse, Shane? What is the difference between a total eclipse and an annular eclipse, and what does it mean for people who want to go and observe an eclipse?
Right. So they're actually sort of connected. Like when there's an annular eclipse, that's typically a precursor to a total eclipse. I believe it's a precursor. And they kind of happen in close proximity to each other in terms of the calendar. Now, a total eclipse is one of the most spectacular things I think that you can ever see with your eyes. And that's when during the daytime, the sun is up in the sky, the moon will pass exactly in front of the sun from a point on the earth. Like there's a totality path that you have to be within to see this. And when the moon, during a total eclipse, the distance, of the sun, the earth, the moon is such that the moon is basically the same size in the sky as how the sun appears, and then blocks basically all of the sunlight. And during a total eclipse, during the brief moment of totality, you can actually view the sun without any protection on your eyes. And you're not really actually seeing the sun. You're seeing the moon in front of it, but there's some neat diamond ring effects that are just spectacular to see. So that's a total eclipse. In annular, that spacing is a little bit different between the sun, earth, and moon. And essentially the same process is happening where the moon is passing in front of the sun during the daytime, but it's not blocking out all of the sunlight. In fact, there'll be, if you're on the path of totality for an annular, there'll be a very bright ring of sunlight all the way around the moon. And this will damage your eyes, cause permanent damage, potentially blindness. So you still require protection or proper filtering 100% of the time during an annular solar eclipse.
Yeah. So warning, do not look at an annular eclipse without special eclipse glasses that you've sourced from a reputable source that have the ISO seal, and also you can't look at it through a telescope that doesn't have a proper solar filter. And if you have any kind of question about how any of that works or anything, the best thing to do is to reach out to your local astronomy club, and they will connect you with how to see that event safely if it's visible in your area. And for example, Shane, now I've got a lot of the special solar glasses and filters, but honestly, when I really want to get a good look at the sun, I reach out to you because you're the solar observer between the two of us, and then I kindly ask for a look through your telescope.
Yeah, and the views through a telescope with the right filtering are phenomenal. And if you're in the path of this annular, I would definitely make every attempt at observing it, whether it's with your own gear with the right filtering, or like Chris said, meeting up. I guess with COVID there may not be as many public outreach events, but if there is a public outreach event being hosted by a local club, check it out. It'll be a neat thing to observe.
Yeah, and the areas that it's visible at are, I think, northern Russia, Greenland, and northeastern North America. It actually comes not too far from here, being a 1,300 kilometer drive from where we live in Saskatchewan.
Yeah, that's a little ways away, and unfortunately, we won't be able to do that. Oh, well.
That's right, because there is a 600 kilometer no-go zone right now. Unfortunately, the largest outbreak of COVID in North America, one of the largest outbreaks of COVID in the world. Unfortunately, it's getting much better here. It's getting much better in the rest of Canada. But between us and where that eclipse is a no-go zone right now, unfortunately.
Yep.
And we're not really expecting that to change enough by that date. If it does, though, I think I have a spare day off that I can pull out of the hat. And I recently tried to make sure that things are going very well at work, and fingers crossed. And I've got enough chits in the jar that I could pull out the day if things get really, really good here over the next couple weeks, I guess.
Well, hopefully it works out.
Yeah, there's great information on the NASA website. If you go to nasa.gov, there's great information there about where the eclipse is occurring. But again, we say, do not look at the sun. This is not an opportunity to look at the sun in any way whatsoever. If you do look at the sun, it definitely will cause some damage to your eye. And like Shane said, it can even cause blindness. So we do give that caveat. And I was going through this in my astronomy class that I teach. And even after I gave all those warnings, I had somebody contact me and say, I want to go and see it. I said, well, what kind of solar safety protection do you have? And the person said, none. I said, you cannot view it. You need solar safety glasses, or you need a special telescope. And if you're not really sure about all that, then you just can't be going to take a look at the sun. This is not something you can see without significant solar protection and having the solar safety glasses, which look like a Mylar filter, although I think they sell some polymer ones now too. They're available on the internet, and certainly there's lots of this gear around. I have some of them. But of course, during COVID times, we're not getting together with people to hand them out, unfortunately.
Yeah. Oh, well, what to do?
Yeah. We'll catch the next one. Yeah, I kind of thought we might drive up for that because it'd be a 12-hour drive. We would just have to stay in the COVID zone to make it. Unfortunately, we'd have to stay over there at least one night. So that's probably not happening. All right. So on June 11th, we're going to have Venus and the moon in the western sky. And this is going to happen right after sunset. And this is something that's safe to look at. And in some, I should say this, in some areas, they're just going to be 1.5 degrees apart. But I think for us, Shane, it looks like they're almost closer to 10 degrees apart. And how far is 10 degrees for those that don't know what a degree is?
If you hold your arm out, like straighten it out and make a fist, and then hold that fist up against the sky, the width of your fist is about 10 degrees in the sky. And it just holds true for no matter how tall or short you are, because just about, we're all sort of built with the same proportions, that will hold true for everybody for the most part.
Yeah, so I think in Eastern North America, I think just looking at my charts here, I'm thinking that they're going to be a little bit closer, probably, favoring the further east you go, and maybe like the UK. And I know like we have listeners in the UK, and this, I think that might be, it might almost be on the other side. It might be 7 or 8 degrees on the other side of Venus. But I'll be curious to know. I know that they will chime in and let me know how my celestial forecasting goes.
Yeah.
So on the 12th, we're going to get a bit of an alignment there with Venus, the moon, and Mars actually being aligned in the sky. So they're gonna be lined up, and now they're going to be sort of spaced out. It's going to be more like something you're going to see just with your eye, but sort of looking up from the southwestern horizon. You're going to see Venus very bright on the horizon, and then just above and to the left or to the northeast, you're going to see the moon, and then almost equidistant to the northeast, you're going to see Mars forming this sort of arc in the sky. And I think that this is really, for the most part, considering most people aren't going to see the eclipse and they're not going to have the special gear that you really need to look at it. Some people will, and some people might be in that area. But I think that this alignment of Venus, the moon, and Mars is something that people looking at the sky to the west on the evening of June 12th are going to see and say, that's going to look like a beautiful sight for taking a photo.
Yeah, I think it's a great opportunity. And like you said, you don't really need the specialized gear. You can just use what you have.
Yeah, I think like with binoculars, you can kind of visit each of those. If you have really wide angle binoculars, like a 9 or an old pair of binoculars that might give you 10 or 11 degrees, you might be able to get like Venus, then the moon, and then Mars. But I think at their closest points, they're around like you said, about 10 degrees or the fist at arm's length.
Yeah, for sure.
And you should be able to see that one because it's right in the evening. It's right around bedtime, Shane. You'll be good.
Gee, lucky me.
Good stuff. On the 13th, the moon and Mars, they kind of get within a decent close approach, and the best time we can see it here in Saskatchewan is going to be about 10 p.m. But yeah, in the early evening, no matter where you are on Earth, you're going to be able to see the moon and Mars pair up as close as 3 degrees even, I think. And here they're about 4 degrees for us. So within the view of a pair of binoculars. So if you're wondering about seeing a planet like Mars, all you need is a pair of binoculars, and on the evening of the 13th, you can just use your binoculars and put Mars sort of in the upper left or to the north east, and then in the bottom right to the southwest, you're going to see Mars.
Yeah, there's the nice thing of these close pairings is it gives people an opportunity to easily find and observe a planet, because everybody can find the moon. And sometimes finding a planet is a little more difficult, but June the 13th is a great opportunity to see Mars. Now, we talked a little bit about Mars detail at the start of this episode. Even with a telescope, unless you have a huge telescope, you're likely not going to see any of the detail on Mars. But the moon, even through binoculars, looks phenomenal. And then to have the moon paired with, this orange planet is going to be a neat thing to see.
And it's fun. Like so you although you can see the moon on many nights, and Mars, like we were saying, just kind of looks like a star. Like in our own little group of amateur astronomers, on these nights, if it's looking clear, like we get busy with life and might get focused on other things, and then one of us will sort of send a text out saying, hey, it's clear, and this is the night when the moon and Mars are together in the sky. Take a look at it with your binoculars. And then we'll get on. I'll say, hey, it looks like it's 5 degrees apart, and somebody will say, no, it's 4, and stuff like that. But they do look really pretty in the sky together. And because it's not something you can see just on any given night, there is a special nature to it. That it will occur sort of a few times over the course of a few months, and then not occur for an extended period of time.
Right. Yep.
So the 18th of June, that's when we have our first quarter moon. And then on the 21st, we have the summer solstice.
Yeah. Yeah, which is sort of to me, it's like a double-edged sword. The summer solstice represents the longest day of the year, the most amount of sunshine. Now, the good news is that every day after that, the nights get longer, which is awesome for astronomers because we get more opportunity to observe. But for us in the northern latitudes, that also means we're getting closer to winter. As every day gets a little shorter, we know that winter is coming. So that's the double-edged sword aspect of it for me. But as an astronomer, June is a bit of a month where you change your observing habits, because at least where we live, Chris, in the northern latitudes here at about 50 degrees, it just really doesn't get dark for us until probably the third week of July.
Yeah.
And then, progressively darker, or I shouldn't say darker, but the dark period of the night grows. It lasts longer as the calendar, continues to turn.
Yeah. And it's something, so I'm originally from areas a little bit further south. And I think that this is about the point at which you really notice it, because when I moved here, and I have never been able to fully adjust to it. I wasn't watching the clock last evening, and it was still bright. And I said to my spouse, I said, hey, let's go for a walk. It's still kind of bright out. So we went out for a walk. We were watching a movie, and then we came home, and then we finished watching the movie, and I looked at my watch, and it was 11. And I was like, whoa, it's getting late. And it was just getting dark. It was just getting dark at 11 p.m. here. And we've still got 3 weeks to go before the solstice.
Yeah, exactly. So, looking forward to it, just so that we can get back to some dark sky observing.
Yeah, I'll never forget. I was at a conference, almost again the distance north as we are from where I grew up. And I was at this conference, and it was one of those things where people are getting up at the end of the conference and giving speeches. And we had like a meal, and the meal kind of went on for a while, but I was sitting with a bunch of my astronomy conference friends, and we were having a good time. And there was supposed to be fireworks. And holy cow, I remember that I looked at my watch at one point. I thought it was maybe like 9:30 or something. And I think it was 12:30 at night. It was like 12:30 a.m. And I was like, oh, this feels very strange, and it was just getting dark, right?
Yeah.
Okay. Yeah. We'll move it. We'll move ahead though. June 24th, full moon. Oh, wait, another super moon for you, Shane.
There's a lot of supermoons in 2021, it seems, at least right now. It seems like every full moon is a supermoon.
Well, I'm wondering if the definition of a supermoon has maybe creeped a little bit somewhere along the line. So these supermoon phenomena are relatively new. When we were first getting into astronomy years ago, nobody ever talked about a supermoon. You had a full moon, and you had a new moon, and the quarter moons, and all that kind of stuff. And then I knew growing up that we had perigeual moons, when the moons are at their closest points, because where I grew up on the ocean, this affects the tides, and we can get flooding. Where I'm from, the water can come over our dock, it can come over our roads. So you're watching for those. They have a very significant meaning. But now I find that that the business of the supermoon and the closeness of the moon when it's full is just simply a matter of is it closer than kind of its like median point. And if it's a little bit close, like a mile closer than the median point, I think they're now calling it like a supermoon. So there's no real context to it at all. And I think it's only around 10% larger. And I think I did run the experiment to see if I could see. And so I'm somebody that with a friend of mine, we actually did a study of the moon and to see unaided eye things on the moon, like the oceans on the moon, which are just lava plains, and some of the larger craters, and this sort of thing. And we also tried to determine if we could see the difference between a perigeal moon that was full and just sort of a regular moon or a moon at apogee. And it turned out that I kind of thought maybe I could see it. I think maybe I can see it as somebody who observed hundreds of moons, full moons with the unaided eye and sketched them. So we're also sketching them and taking detailed notes of what we were witnessing, and then creating a bit of a grid to compare them on our sketch pads. My friend and I, Clark, we thought maybe we could see it, but we were unsure. We were uncertain that we could see a supermoon.
Yeah, exactly. It's it just really means that the moon's a little bit bigger, but it's not, at least for me, it's not an astronomical event that really gets me excited, or it's nothing that I put on my list of things to observe in the month.
Yeah, what we could see though is that rocking motion. What's that called, when you can kind of see sort of the motion of the moon going back and forth, because it kind of tends to wobble a little bit in the sky. So sometimes you can sort of what happens is as our orbits kind of go around, we kind of play a little bit of catch up, or a bit of, sometimes we'll lag a bit. One or the other, the moon will kind of scooch ahead, or we'll kind of scooch behind a little bit. Mm-hmm. So over the course of a month, you can actually see about 59% of the surface, or close to 60% of the surface, something like that. And we noticed that we could definitely see that, because different features will appear to kind of come into view, or to kind of scooch out of view. One is Mare Orientale. But as far as the supermoon goes, from a regular moon to a supermoon, atmospheric conditions definitely are much more noticeable than whether or not the moon is some percent larger or not.
For sure. Yeah. And the wobble that Chris was just referring to is known as libration. Lunar libration.
I always think of libation, which is something I do when the moon is full, because we can't go doing astronomy. Okay, so June 27th, Saturn and the moon are as close as 4 degrees, but a bit further. Again, this one's not favored here in Saskatchewan. I think here they're about 6 degrees apart in the sky. But what this allows you to do, no matter where you are, is that Saturn and the moon. So if you want to see Saturn in the morning sky, you can actually identify it. So maybe you're somebody that's never seen a planet for themselves, but you're able to see the moon. And so on the morning of June 27th, so this isn't the evening of June 20th, this is in the morning, so you'd be getting up early. The moon and Saturn are going to pass pretty close together. 4 degrees is usually about, that's usually going to be well seen within most binoculars. Most binoculars are at least 4 degree fields of view. So with a decent pair of binoculars, you'd be able to see the moon and Saturn. Now you can actually see Saturn with the unaided eye. I was out just looking at it yesterday morning. And I know where to look. I know where it is in the sky. But if you were a newcomer and you weren't really sure where to look for Saturn in the morning sky, well, on the morning of the 27th, Saturn is going to get pointed out by the moon, because it's going to be the closest, brightest star to it, being just about half a fist's width right above the moon.
Yeah, very cool. And then I think we have another opportunity with Jupiter like that, don't we?
Yes. Let's see, just 2 days later, on the 29th, Jupiter and the moon are going to be the same thing, 4 degrees apart. We're going to have the moon just below Jupiter. Although for us in the sky, it's going to be scooched over a little. I think the first time they're a little bit further than 4 degrees apart. For us in other areas of the world, they're going to get as close as 4 degrees. And then on the morning of the 29th, the moon is going to be a little bit to the east of Jupiter by about 10 degrees for us here in sort of north central North America. But for other folks that are to our east, they're going to be able to see them line up again, like probably over in places like the UK or places around where I grew up, like in the Maritime provinces, or over in Maine as well. You'd be able to see them lined up a little bit better.
Yeah, yeah. And then we end the month with yet another planetary pairing that will make it easy again or easier to observe Mars if you've never done it.
Mm-hmm.
On June the 30th, just around sunset, Venus and Mars will be 7.5 degrees apart, which is in the constellation of Cancer. So very close. And at that point, so Venus will be pretty low on the horizon, kind of northwest, and it'll be the brightest thing next to the moon in the sky. And in fact, some people, report UFO sightings, but it's really just Venus because it sort of almost looks like it pulsates because of the atmosphere distortion. But anyway, look for those two planets on the 30th.
Yeah, we did have a UFO sighting here. I really wish I knew what it was, but I was reading an astronomy book, and they didn't reference these as being UFOs, but it's amazing the things that can be seen through a telescope. So some early observers were observing when the sky was very bright, and it turned out that they were seeing these strange objects quite frequently, and they were seeing seeds. And then on another occasion, some observers over in Africa were observing, and they saw some strange things in the daytime sky, and they were locusts. They were swarms of locusts.
Wow.
And then on another occasion, somebody saw hail. It just happened to the way that the hail was falling, and it was at a great distance from a cloud that was very high. And so there's a lot of different things that you can see in the sky that can kind of play tricks on you. Meteors can kind of come in and skim the atmosphere, and that sort of thing. But yeah, no UFO sightings for us, unfortunately. To say the least.
Yes.
Comets, though, no comets either.
None bright enough for a typical amateur telescope. And even if you had large telescopes, they're probably not going to show any detail, but it looks like nothing brighter than 11th magnitude, which is pretty dim. Yep.
Yeah, so an 11th magnitude comet would be difficult to see. You think about an 11th magnitude star, doesn't start to get easy to see until you get about a good 3-inch telescope or so. And so this is going to be quite a bit more difficult to see than that. So anyway, we're not going to get into such faint things. But what about some clouds this month, Shane? Cloud watching and astronomy?
Yeah.
What?
Yeah. So June is probably the best month of the year to look for noctilucent clouds. Now, typically, you do need to be a little bit more north. So like where we are at 50 degrees is an ideal latitude for seeing these things. Now, what this is it's a cloud that you see after the sun sets. Now, that's not uncommon. Sometimes after the sun sets, you'll see black silhouettes of clouds in the sky.
Especially
that's
where I
normal.
grew up.
Yeah.
we saw lots of clouds growing up.
Yeah. Now, what is interesting about the noctilucents and why you can only see them in June. So we talked about the perpetual twilight that happens here. The perpetual twilight happens because when the sun sets, it is really just below the horizon as the Earth is rotating. And that, keeps the sky sort of illuminated to a certain degree.
Mm-hmm.
Now, what it also allows to happen is the sun, even though we can't see it because it's just below the horizon, some of its light can still reach very high altitude clouds. And what can happen is this phenomena of noctilucent clouds is you'll see these clouds and they look like daytime clouds, like they're white, they're lit up, they're bright. But the thing is, it's not daytime. The sun has set. In fact, the best time to see these typically is around 90 minutes after sunset.
Yeah.
And they're the coolest thing. Like they are really neat to see. And, if you're out this month after sunset, look to the north because that's where you'll see them in the northern sky, usually or northwest. And if you see white illuminated clouds and the sun has set, you've recorded a noctilucent observation.
And they're a very particular kind of white, almost like a bluey white, and they're sort of almost like neon white in a way, I suppose, as well. And so where I'm from, which is only about 7 or 8 degrees further south from where we live, I don't think I ever saw them. We had lots of clouds. I mean, so many clouds that there could have been noctilucent clouds there too, but we had lots of clouds. So we weren't seeing any noctilucent clouds. But I think just by being a little bit further north and by having, we have really good horizons here, you can really see them. Usually we get a couple good sightings of them every year, even from the city. I've seen them a few times.
Yeah, I've seen them multiple times from the city, and they often, I don't know if there's any science behind this. This is just what I've observed, is that it happens in during the night when like there's no clouds in the sky at all. It's a beautifully clear evening, and then these things appear almost like ghosts in the northern sky. All of a sudden, you'll start to see. In fact, sometimes I think I'm seeing aurora, like the northern lights are starting to form. Yeah. But then I watch, and they don't really change shape or evolve like the aurora does. And then it gets a little darker, and these things become a little brighter as a result of the contrast. And then you realize you're looking at noctilucent clouds.
Yeah, and correct me if I'm wrong, because you put this note in, but I'm glad you did. I always forget to mention them, but I am always looking for them at this time of year. But aren't the noctilucent clouds simply the remnants of micrometeors that have entered Earth's atmosphere, burned up very high in the atmosphere, I think like around 70 or 80,000 feet. They get coated in a little bit of the ice and moisture that's up there, and then because of that, it has sort of this sort of unique reflectivity versus the sort of clouds that form lower down in our atmosphere.
Well, there's a few theories about what the cause is or what they are, but I don't believe anything's been proven as fact yet. There's another theory out there that it's I don't know, I guess exhaust or leftover, I don't know, maybe pollution from airplanes, because the noctilucent observations, I think, are also a recent phenomena. Like 100 years ago, I don't think there was any noctilucent observations that were recorded, at least. Maybe people were seeing them, but it does seem like a more recent phenomena. And some people then, go to the well, what do we do high in the sky that might cause that? And, so anyway, I think there's a few different, again, theories or hypotheses about how they form, what they are. The interesting thing is, there's science that needs to happen on these things to gain a better understanding.
Yeah, and certainly we're amateur astronomers, so we're not scientists in that respect. I do work in science, but not in that field. Let's see. What's interesting about that comment, though, is this, and that's that, and and I'm certainly not looking to reduce humans' impact on the environment of this planet, which has been unfortunate in many circumstances and continues to weigh heavy into the future. But last year, during the pandemic, early stages, when there was almost a complete stoppage of air travel in our region and in all regions of the world, is that you and I made several noctilucent cloud observations. So it's kind of, I do take note of that. I noticed that we are getting more aircraft now, quite a bit more, and we've had a lot of those large kind of contrails that kind of spread out over the whole sky and, kind of unfortunately ruin the observing when it's very still up there. That the contrail just kind of seems to spread, and then you get 3 or 4 of them, and then they start crisscrossing, and it seems to just about take over what seemingly would otherwise be a clear sky. But I haven't seen any noctilucents this year. But anyway, that's sort of my own little anecdotal observation of it. But I look forward to hopefully seeing some later this month.
Yeah, for sure.
And let's see. What about the sun? How's the solar activity? You're our solar expert, our solar amateur observing expert.
Yeah, well, I do enjoy observing the sun. And the sun goes through roughly 11-year cycles of activity, where the activity goes from a maximum to a minimum. And when I'm talking about activity, it's more so with sunspots. The sunspots on the sun are not only really interesting to observe, but it indicates that the sun is potentially active, and then that can also send like particles towards Earth, which cause the aurora, but can also cause other disruptions with satellites and electronics. But the point of this note here is we had just come out of the minimum, or we were in the minimum of the last solar cycle. It was believed that that cycle had ended, and we were waiting for the new solar cycle, which is solar cycle 25. We've been waiting for it to intensify and begin to ramp up to its maximum activity. And it looks like that intensification is occurring right now. There are a number of sunspot groupings, well, a couple at least, 2 or 3. I've observed them a little bit earlier in the week. I'm going to observe them again today. And the reason I'm mentioning this is if you have the right filtering for your optics, whether it's a camera, a telescope, binoculars, if you have the right filtering, start looking at the sun, because you're going to see more detail. And there is a lot of detail to observe within sunspots and within the groupings of sunspots. And it can make for just another way to enjoy the sky. I think astronomy is often thought as a nighttime hobby. But the closest star to us is our sun, and there's an awful lot of observing that you can do during the daytime. And it's looking like it'll just get more and more interesting.
Well, I feel like that was a very beautiful and eloquent monologue on the sun, Shane. So I think we should maybe we should stop there. No, I think that was really nice. I really enjoyed hearing that, and I think by me talking any further, it's just going to diminish the impact of your statement.
Okay, let's call it a day.
All right. Well, thanks for listening, everybody, and we'll talk to you soon.
Thank you, everyone, for listening, and we hope you enjoyed the show. If you are interested in more information, would like to contact us, or if you would like to support the podcast, check out our website, actualastronomy.com.